This table is kind of annoying.
Yeah, I was thinking the same thing. But I don't think we
That's all right. Cool. Yeah, I'm gonna talk about type overloading and why you should be careful about type overloading. For us recently, actually was for us. Just so he's to blame.
The only reason why I was the one who wrote that issue is because you were playing Age of Empires. Otherwise, you might have done it.
Maybe you should have too. Then we wouldn't have had any of these issues. Anyways, we recently made this issue on Node, and it turned into a whole thing with 203 comments. And there's some pretty good ones in here. Somebody's like, "You should all perish in flames," and yeah.
Oh, that's Tomas Tashek. He's a professional troll.
Yeah, guess so. John, this is why you need an avatar,
Right.
because otherwise, yeah. Anyways, so what's the problem? So
Yeah.
who in here knows about buffers in Node? All right, cool. So how do you create a buffer from a string? You do node hello world, right? That creates a buffer that contains hello world. How do you allocate a new buffer in Node? Does anybody know? You do a new buffer, some bytes. As you'll notice, these buffers are not zeroed out, which is perfectly fine. Just go read the docs. The problem here is that these two methods kind of do two very different things. One turns a string into a buffer, or any value into a buffer. Another one allocates raw memory. This is fine if you have types. In Node, we don't have types. So usually in code, you'll see something like this. Like new buffer, some variable. What can that variable be? It can be a number. We get raw memory. It can be a string. We get a string as a buffer. So that's probably fine. We're all good programmers. We won't never make this mistake, except we do this mistake all the time, it turns out. So I'll show you how. Mean for us, and I guess how many contributors are there on bittorrent-dht? There's a bunch.
A few other, yeah.
Substack. How a lot of Node people got this all wrong and ended up creating a bunch of security issues and big modules, and you should all be scared. And everything is fucked. Anyways, there's this cool module called bittorrent-dht that me and Faraz wrote a while back, and it's probably one of the most used Node modules, I would stipulate, in actual programs. It's in all the BitTorrent clients in Node. It's probably in Popcorn Time, I guess.
Yep.
It's probably in all the whatever derivatives of Popcorn Time there's out there. And it turns out we had a huge security issue in this module because of the issue I just showed. So I'm gonna try to explain why. So if you go to README, I should just say also we fixed it, so it's fine now, hopefully. But update your code, please, if you haven't. It's a major bump. You should. Actually, we fixed it in a patch first, right? Yeah.
And all the old versions are deprecated.
Right.
So if you ever install them, even as a dependency of a dependency,
Right.
you'll get a warning.
So hopefully you read that.
Yeah.
So here's the problem. This DHT builds a DHT, and it has this method called addNode, and this addNode takes an address and a node ID. That's all good. If you go to the actual implementation of this, it's called internally. It ends up calling this underscore method, called addNode. Where'd it go? There we go. And this internal method calls, you pass in an address, a node ID, and a from. It doesn't really matter what from is, but as you can see here, it calls this internal method called ID to buffer with a node ID. And if we look up that method, whoa, so many references. There we go. This is how ID to buffer looks. So this is a very normal pattern in Node because, you know, we got buffers, but buffers are kind of annoying to type on the command line because you can't. So usually on a command line you would type a string or something like that, or like you will get a string as username. But internally in this module, we need a buffer because it's a low-level module. So we usually have a function like this that says, oh, if it's the buffer, that's fine, then it's already a buffer, let's just return that. Otherwise, let's convert it into a buffer. The only problem is here that if you pass in a number, that won't be a buffer, then it will call new buffer number and it will allocate raw memory. So that's pretty bad. So it turns out that if you call add node with a number, you get raw memory, and this raw memory can be anything that's in your module. So if you have a password in there, if you have your name in there, you might be exposing it. So okay, that's probably fine. We probably don't call this method anywhere critical. Well, it turns out we kind of do a lot. So I'm going to try to show you why.
It's worth mentioning too that the memory that might be revealed is memory from the same process, the same node process. When the OS gives a process memory, it's usually zeroed out on all modern OSs. So it's going to be like, could be whatever stuff is in the node process. So that could be your source code, or if you have like passwords or stuff in the same process, that would be revealed.
Yeah. So just going to install. This is the latest version of bittorrent-dht that still has the vulnerability. So I installed 5.1.2. So if I just quickly, whoa, I don't know what that was. Probably some fragment. DHT. So if we just create a new DHT instance and we say bootstrap false because we don't really want to connect to the bittorrent network right now, but it doesn't really matter, it's just to make it. So we don't DDoS this entire connection. And we can call listen, and then I think it emits ready, right, in this version. Mm-hmm. And everything is fine. So this is how most of the bittorrent clients use the bittorrent-dht. They basically spin up a DHT and some port. Could also be just a non-deterministic port, doesn't really matter, it's just for testing. And if you run this, you get it. Everything's fine. Oh, why? Oh, I think it's because I have it running somewhere else. Oh. Cool. So, perfectly good. So here's the issue. So let's say we create a UDP socket. So this DHT is running over UDP. If you don't know, doesn't really matter for this, and it's sending something called Ben encoded messages. So this is another big part of the problem because BitTorrent is using a format like JSON that doesn't have any schemas, which is really, really convenient when you write it, except that you have to type check everything very defensively on both ends because people can send a number as a string or a string as a number, and the parser will just say, hey, everything is fine. So yeah, that's also not that cool all the time. Anyways, there's this method we can call in the DHT called findNode, and it basically works like this. You can send a message where you say, this is a query, the query is findNode, and it contains this data, where you send an ID that's just 20 bytes, that's your local name. Hello, I am Matthias, is that 20 bytes? Let's see. That, almost. And a target, which is an ID you're looking for. It's just a generic DHT operation. So I'm just going to send 20 empty bytes. So I can send this using the socket by doing send message message length. It was running on port 9000 on localhost, and then we get a message event back when something happens. I'll just print it out so we can see that it actually works. Okay, so we create this message that calls the method on the DHT, and let's see what happens. Oh, I need to install this guy. Oh, I need a transaction ID here also, I guess. Right. Is this correct for us? Do you know?
I don't remember.
Is it find node or find nodes?
Find nodes, probably.
Anyway. Queuing.
Bold move to be writing that by scratch.
Yeah, I have it somewhere though.
Well, that coding always works.
It's find nodes, I think.
Find nodes?
Sorry, find node one, singular actually.
Okay. Local host. This thing is. I have it here also. I'll just copy this. Target ID.
I think the transactions ID is supposed to be a string too.
No, it's not.
Oh, it's not. The spec is wrong.
0. This is correct, right? Let me just say, check this comes here. Message. Oh, now it works. I probably had a typo somewhere. Cool. Probably didn't save it. Oh no, it didn't work. I'm just printing out my own message. That's cool. Localhost. Oh, maybe I should run the server. There we go. So we get the message back, and this is a reply from the DHT, and we can just do decode and print this guy out. So let's see how that works. So this is a reply we get back from the DHT answering our find node message. And it basically just says, hello, I'm the DHT, this is a reply, and this is my ID, and this is the answer to our query. So it doesn't have the ID we're looking for, but it tells us to access these nodes instead. And if we print out that nodes thing as a string, oops, it's R. We'll see that we get my message back. So this is my ID. So, interesting. So we can actually get the bittorrent-dht module to echo our own IDs back, because that's how Kademlia works, and this is using Kademlia. So if we know about this vulnerability, that buffers have two methods, one that creates fun from a string, one that creates fun from a number, it's calling the same thing. What happens if we just put 20 in here? Well, let's try it. We get this random data back, and we still get hello Matthias, because that was the previous message. It'll send back more than one ID. If we run it again, get more random data, more random data, more random data.
Yeah, that's okay.
So here we got like an error thing, because in the process memory there's an error string somewhere, and we can kind of like just continue doing this.
Oh, Chinese.
Until we at some point would it's very undeterministic.
Actually, you know,
Private key, private key.
if you made a variable called password and like put it in this, just put it in the source code, I bet you would get it echoed out.
Is there a way to multiply the amount of times you do something?
Oh yeah, so
20 something?
so first of all, to answer your question for us, I tried that, but it's kind of hard to. So the question is, if I put in some source code into the server, could I find it? And yes, you can, but it's a bit more tricky than you think, because this guy up here requires like thousands of lines of JavaScript. So you'll get it at some point. Yeah.
So you could like get a big buffer and do sequence alignment on it.
Do what? Sorry.
Sequence alignment,
Mm-hmm.
and then just reproduce an image of a memory.
Yeah. Yeah. So, Richard, to answer your question, it's pretty easy actually, because what you do is you just.
No, my question was actually to, in the terminal, instead of typing it over and over again, you can just make a loop in bash and just do it 20 times.
Yeah, do like this also. So, if we just keep asking it for memory, we'll keep getting back. At some point in time, this memory that it's disclosing will be stable, because Kademlia will only return a certain amount of data every time, and we're filling up a table, we can keep hitting it, but the pipe becomes less and less. But we can sometimes fix this, because can anybody figure out what would happen if instead of putting 20 here, I put like 20 million?
Your computer's gonna break.
Right. So
Take down 4.
I can also crash all BitTorrent clients by just doing this. And that's not even anything to do with zero-out memory. So if we're really lucky and the BitTorrent client is running in like a daemon manager, you would be able to do something like this, where you would say if tick plus plus modulus, let's say 100, then crash it, I guess. Oh, not crash it.
0.
Yeah. So this is a talk about not being too clever, and I'm writing really clever code right now.
You're gonna crash 99% of the time.
Yeah. So by crashing it, we get it to reset its memory state. So let's try this.
Too clever.
Too clever. Oh, that's because we're doing this stuff. And this one is the one where we crash it, I guess. So I guess we should print out tick also. And set this to 50 or something. So now every 100th message, it will crash the BitTorrent client and get it to reset its state, and we'll get new memory back. So this is a very easy way of, at some point, get the server to disclose something super interesting. Yeah, that's basically it. So yeah, the trick is type check your things always. It sounds easy, but you forget and you become too clever. We found multiples of these in all kinds of modules. There was one in WS also. I think Faraz found some in something else also. Request has one. Oh yeah, and request, if you send form data. Is this disclosed?
Yeah.
Okay.
Not fixed yet though.
Okay, but it's okay. I won't say that one.
Something form data.
But basically, in WS, if you accidentally call send with a number, it would also just dump raw memory out to the user. And the cool thing about that is that that's the same process that usually has HTTPS keys also. So
you can hard bleed it. Oh, that's
Did the node security guys get back to you?
the node security project. Yeah, they published some like, security advisory things about it, and
But they didn't add it to their static analysis tool.
what do you mean?
So the node security project.
I think they're checking for it now. I think they're also checking for it before.
They mark the versions as vulnerable. So if you're using their module, it'll like warn you if your package JSON contains a vulnerable version.
I also think they're checking for new buffer now.
Right. Oh, that's what I meant. Like,
Yeah.
the static analysis that like checks all node modules for certain patterns of sadness.
Yeah.
The problem is that the static analysis tools aren't very good. So they're like in general in JavaScript, they're just not like as good as in other languages. So I think the best they can do is look for a new buffer and then like a literal number. Because if they just look for like new buffer anything, then like every module would be probably would come up as a false positive.
Yeah. So the trick to this is type check your thing. Don't think that just zeroing out memory will help you, because you can still crash other programs even if they zero stuff out if you have this vulnerability. You probably already have this vulnerability, because I feel like the number of modules we looked at that had this issue after doing new buffer is kind of high in some way or another. So yeah, just be scared when you do new buffer. That's it. Thank you.